Welcome to the 2017 AP Statistics FRQ exam. In this video, we're going to specifically looking at question number 1 and fully explain the answers as best as I can. This is actually a really easy question dealing with scatter plots and correlation in lines of best fit or least squares regressions lines. Hopefully, you'll find that it's not too bad at all. All right, so here's the problem. Researchers studying a pack of gray wolves in North America collected data on the length X in meters from nose to tip of tail and the weight Y in kilograms of the wolves. A scatter plot of weight versus length revealed a relationship between the two variables described as positive, linear, and strong. So apparently we had a scatter plot where the X was the length of the wolf measured in meters, and the Y was the weight of, the weight of the wolves measured in kilograms. And we're seeing a positive, linear, and strong relationship, maybe something that looks something like that. Okay, so what do each of these words mean? Well, a positive relationship means that as the explanatory variable increases, so does the response variable. So there must be a tendency that as the length of a wolf in this pack increases, so does its weight. Easy. As X goes up, so does Y, but make sure you have the context here. As the length of a wolf goes up, there's a tendency that its weight increases as well. Now, a linear relationship is one that has a constant rate of change. That is so important. A lot of kids don't truly know what linear means. They just, it makes a line. But a line is a relationship that has a constant rate of change. It's super vital to your understanding. So as the length of a wolf increases by 1 meter, the weight tends to increase at a constant rate. It's not just that the weights of the wolves are going up by whatever they want. It's that the weights of the wolf are going up at a steady, constant rate. We don't currently know what that rate is, but we do know that whatever the rate of increase is, it's staying constant. That's a key feature of linear. Whereas a curve, like an exponential, that is increasing, but at an increasing rate. So it's a little bit different there. All right, what does strong mean? This means that the data points fall close to a line, meaning that the data points strongly form a noticeable line. If we're going to say something is positive in linear, and on top of it, the positivity in the linearness of the line is strong, it means that those data points are very closely forming a straight line, making it very easy for me to see that. All right, that was part A. I thought that was all pretty simple, not too painful. Part B starts off by saying, first, the data collected from the wolves were used to create a least squares regression line. So here's what they actually tell us, that a least squares regression line was found. Now let's make sure we walk through this real quick before we dive into the questions. First off, why a little hat on the Y? Well, why hat is making sure that you know that this equation is used to make predictions based on the least squares regression line. This equation will not have you find the actual weight of a wolf. It's just what we would predict for a wolf based on its X or its length. So we have two numbers here. First in alphabetical order is A, that is the y-intercept. That's what happens when a wolf would be 0 meters long. We would predict its weight to be negative, which doesn't make a lot of sense here. Could be because of extrapolation, no big deal. And then we have the, not necessarily the more important number, but a pretty important number here as the slope of this equation. That's the constant rate we're referring to earlier when we said that it was linear. All right, so part B wants us to interpret the meaning of the slope of the least squares regression line in context. So first, it's important to actually identify the slope as the 35.02. It's the number that's being multiplied by X. It's not that first number. It's the second number. I guess you could write this in a different order. You could put the 35.02X first and then the negative 16.46 in the back. But the key thing is, remember, slope is what you're multiplying the X variable by. All right, now I personally like to actually take the slope and write it as a fraction. And any number can be written as a fraction by putting it over 1. And if you think about slope back from maybe middle school, we have change of y over change in x. So the x is the length in meters, and the y is the weight in kilograms. Sorry, I'm squeezing that in there. So if you write that out, then it actually makes it pretty easy to explain. So as the length of a wolf goes up by 1 meter, we predict the weight to also go up by 35.02 kilograms. That's a pretty simple interpretation. Now, keyword is make sure you have predicted here, because we want to emphasize that this is not guaranteed to happen. So it's not like if a wolf grows 1 meter over the course of a year, it's guaranteed to increase by 35.02 0.02 kilograms. It's just a prediction that will happen on average. So if we looked at all these wolves in this pack as a collective group, on average, as they increase by 1 meter in length, we predict their weight to increase by 35.02 kilograms. All right, the next part wants us to figure out the actual value of a wolf. They give us some information here. One of the wolves in the pack has an actual length of 1.4 meters. So that's an X value. It is a length in meters. And its residual value is negative 9.67 kilograms. What was the weight of the wolf? Now, first, we do have to remember our formula for residual. A residual value is the actual Y minus the predicted Y we get from the least squares regression line. So this means that if I were to add the predicted value over, the residual plus the predicted value is the actual value of the wolf. So I know the residual value is negative 9.67. Now all I got to do is figure out what the predicted weight for this wolf is, and I'm going to use the 1.4 because that's exactly what my equation is for. My equation finds predicted values based on X. So now I'm going to go to my calculator here. Let me slide it over so we can see this. We're going to type in negative 16.46. We're going to add 35.02 times the actual length of this wolf was 1.4. So we get that this wolf was predicted to weigh 32.568 kilograms. All right, so that's it. Just filling in the blanks there. Now I can do some quick math to figure out the actual weight of this wolf. All right, so I'm going to take the negative 9.67. That was the residual value of this wolf, which means that its actual weight was 9 pounds below predicted. So I'm going to add the predicted weight, the 32.568, and I get that the actual weight of this wolf was 22.898 kilograms. And that should make sense because remember, don't forget the unit there, kilograms, because remember a negative residual means that the actual weight of the wolf was well in this case, I'd say well below predicted. 9 kilograms is kind of a lot. So well below predicted. So this actual wolf weighed 22.898 kilograms, even though we predicted it to weigh 32.568 based on our equation. All right, that's it for this problem. Again, I think it was pretty simple, just really making sure that you understand what positive, linear, and strong mean, and how to interpret slope, and then again, how to actually work with residual values. Not overly difficult. Hopefully you find it a pretty easy problem, and you can score a pretty good score on it. All right, see you in the next video.